Okay, let's work through your Unit 4 test review. So it says the test has several questions straight from the assignment 4.1 and 4.2. Your best review would be to redo and practice the assignments 4.1 and 4.2 multiple times where you have seen multiple versions of each question. Here are a couple of the problems to review as well. Do not worry about the word problems from those assignments. So these are the topics that you're going to need to know from 4.1, so make sure that you're focusing on these topics. And then these are the topics for 4.2. There's not many questions from 4.2 on there, so really make sure you know 4.1 because most of that assignment will be covered. Whereas 4.2, there were two different types of problems we talked about. We talked about solving equations versus solving inequalities. So you'll just have to make sure you understand each of those processes. All right, number one, it says if f of x equals 1 over x, meaning it's a rational function, is transformed to find f of x equals -1/2 minus 3 over 1/4 x minus 1/8, describe the transformations and identify the following traits. So first, let's rewrite this equation so that it's a little easier to work with. We're going to move this -1/2 to the end of the equation, and then we're going to move this negative that's right here up into the numerator. So we will rewrite it as f of x equals -3 over 1/4 x minus 1/8, and then minus 1/2 on the end. So when we do that, the -3 is going to be our a value, the 1/4 would be our b, the 1/8 is our c, and the -1/2 is our d. Alright, so the reflection, when we look at this, the only one that has a negative is the numerator, so this is only going to reflect over the x-axis. Our vertical stretch, so this comes from our a value, because that's the only one with the negative. Our vertical stretch or compress comes from our a value also, and that's our 3. So since this number is greater than 1, it's going to stretch vertically by 3. Alright, the horizontal stretch and the compress comes from your b value. So you have to think of this as like inside parentheses. So since it's 1/4, this also has a stretch, and the amount it's stretching by is 4. So since this is a fraction inside the parentheses, it's actually a stretch, and then you flip this, use the reciprocal of the 1/4, and you get 4. Your horizontal transformation, if you remember, is c divided by b. So I'm going to go down here, or over here to the side. I'll probably have to end up erasing this, but c divided by b in our case would be -1/8 divided by 1/4. So you would change flip this. So we're going to keep the -1/8, change it to multiplication, and flip the 1/4. So make it 4 over 1. Multiply across, multiply your numerators together and your denominators together. So we get -4 over 8, which reduces to -1/2. So this -1/2 means it's actually going to go right 1/2. Alright, your vertical transformation comes from your d value. In our case, it's our -1/2, so this is going to go down 1/2. So our vertical asymptote is affected by our horizontal transformation. So since we went right 1/2, our horizontal asymptote would be at the equation with x equals +1/2, because if we go right, that's +1/2. Your horizontal asymptote comes from your vertical transformation, how much you move up or down. And we went down 1/2, so this one would be y equals -1/2. Your vertical asymptotes cross your x-axis, so that's why it's x equals. Your horizontal asymptotes cross your y-axis, so that's why it's y equals. So based on that, our domain, we go up here to our vertical asymptote, would be -infinity to +1/2. Then it breaks +1/2 to infinity. And then our range is based on our horizontal asymptote, would be -infinity to -1/2, breaks around that asymptote and goes -1/2 to infinity. So that's that. Alright, number 2, we want to solve 3x divided by 5 minus x is less than x. So if you remember from when we did this, the first thing we need to do is get that x to the other side. So we're going to have 3x over 5 minus x is less than 0. At this point, in order to subtract these, we need to get a common denominator. So we're going to do 3x over 5 minus x, but our common denominator we would have to multiply by is 5 minus x over 5 minus x is less than 0. So when I do this, I like to go all the way across the top. So we're going to multiply or distribute this negative x into this parentheses. So if I work all the way across the top, I'll get 3x minus 5x plus x squared over our common denominator. And you don't square this because there's two of them. You just write what's common, and what's common is 5 minus x is less than 0. We're going to simplify this numerator. So we're going to have x squared minus 2x over 5 minus x. We have a common term in the numerator that we can factor out. We're going to factor out an x. So we're going to have x minus 2 over 5 minus x is less than 0. So at this point, since it's all factored out, we're going to go through and do our critical numbers. If you remember, critical numbers are anything that makes the numerator or the denominator equal 0. Let's go ahead and do our domain restriction while we're here too. So our domain restriction, our domain x cannot equal 5, and then our critical numbers would be 0, and the 0 comes from this x. It would be positive 2, and then the last one would be 5. So here, notice our domain restriction is can't equal 5, so we have a 5 here, so we have to pay attention to what happens at 5. Alright, so we're going to make our number line now. And we're going to put our numbers, our critical numbers on there. So we have 0, 2, and 5, and then you're going to pick your test points on each side. So I'm going to use negative 10 just because it's easy, and then I'll use 1, and then we got 3, and then 10. Alright, if you plug in negative 10 over here to this, negative 10 would be negative, x, or negative 10 minus 2 would be negative, over 5 minus negative 10. So a negative and negative would make it positive, so this denominator would be positive. So this section would be positive. If you plug in 1 for all your x's, we'd get a positive 1. 1 minus 2 would be a negative. 5 minus 1 would be a positive. So in this section, oops, that should be a positive. In this section, we would have a negative. If you plug in 3, 3 is a positive number. 3 minus 2 is a positive 1. 5 minus 3 is a positive 2. So this section is positive. And then we plug in 10 over here. So 10 in for that x would be a positive 10. 10 minus 2 is positive 8. 5 minus 10 would be a negative, so this section is negative. So based on that, we want less than 0. So less than 0 means we want negative numbers. So I would use from 0 to 2, and those, oh, this whole section, we don't even have to worry about our brackets because this doesn't have an equal to sign on it. It's all parentheses. So it's 0 to 2, u, and then 5 to infinity. So back over here, when we talked about our critical numbers, this 5 isn't even going to affect us because this did not have an equal to sign on it. So that's pretty easy. Alright, number 3, it's going to be the same type thing. So we have 1 over x minus 2 plus 1 over x plus 2 is less than or equal to negative 2/3. So we're going to start this one off the exact same way, and we're going to move that negative 2/3 to the other side. So if I do that, I'm going to move over here in case I need extra room. I have 1 over x minus 2 plus 1 over x plus 2 plus 2/3 is less than or equal to 0. So this one, since we have the equal to sign, we're going to have to pay attention because it might affect us when it comes to domain restrictions. And we'll do domain restrictions at the end. Okay, so we need to get a common denominator throughout everything. So notice we have a 3 for a denominator, x plus 2 for the denominator, and an x minus 2 for the denominator. So let's start with our x minus 1 over x minus 2. So to make this match the other ones, we're going to have to multiply this by 3 over 3, and also the x plus 2 over x plus 2. Okay, the next section that we're working with, we got plus 1 over x plus 2. That's from our equation. So to get this to have a common denominator with everything, we're going to have to multiply this one by 3 over 3, and also this denominator, x minus 2 over x minus 2. Then we have plus 2/3. So this one we're going to have to multiply by the x minus 2, so x minus 2 over x minus 2, and then the x plus 2, so x plus 2 over x plus 2. So, and now that's all less than or equal to 0. So now if you look, all your denominators for each section of this have the same denominators available. Okay, so on this side, we're going to multiply this all together. So we'd have 1 times 3, which is 3, and that means we need to distribute the 3 into this x plus 2. Same thing here. We have 1 times 3, which is 3, so we just need to distribute this 3 into the x minus 2. This one's a little more complicated. We have two binomials that we can FOIL together. So we're going to FOIL this numerator first, and then we're going to distribute the 2 in after we FOIL the numerator. So let's take this step by step. So I'm going to distribute this 3 in first. So I'm going to have, and again, I'm going to go all the way across the top and do what I can. So I have 3x plus 6, that's this section, plus, we're here now, 3x minus 6, plus, we're going to FOIL this out, so I'm going to have 2 times, and if you FOIL this out, you get x squared minus 4, all over our common denominators, which is going to be 3 times x plus 2 times x minus 2. And it does not matter the order that you multiply that, like how you have this written, it doesn't matter the order. So we're going to distribute the 2, now that we have FOILed that out. So we're going to have, and let's go ahead and simplify this numerator. I just looked up and saw that. So we have this 6 and this negative 6 can cancel each other out. So let's go ahead and combine like terms. So we're going to have 6x, and then distribute your 2 in here, plus 2x squared minus 8 over the common denominator of 3 times x plus 2 times x minus 2. And that's less than or equal to 0. So is this one. Alright. I'm going to rewrite this in the correct order. Just, descending order. So we're going to do 2x squared plus 6x minus 8 over that same denominator. And then I can factor out a 2. So if I factor out a 2, I get x squared plus 3x minus 4 over 3 times x plus 2 x minus 2. Always, if you have a common factor, a number that you can factor that out first before you try to completely factor this trinomial. It makes your life a little easier. Okay, so if we completely factor this out, we're going to have 2 times, I need two numbers that multiply to negative 4 and add to 3, so x plus 4, x minus 1, over 3 times x plus 2, x minus 2 is less than or equal to 0. Alright, now that I have that all factored out, let's go through and do our domain restrictions and our critical numbers. So domain restriction, x cannot equal, and that comes from the denominator, negative 2 and positive 2. And then our critical numbers are going to be -4, +1, -2, and +2. So these two on our number line will be affected because this is an equal to, a less than or equal to. And this 3 and that 2 is not going to do anything for our domain or our critical numbers because there's not an X with it, so we don't care about them. Alright, so let's go over here and draw our number line. Put all our critical numbers on there. So we have -4, -2, +1, and +2. And then let's pick our test points. So I'm going to do -10, I'm going to do -3, 0, 1.5, and then I'm going to do +10. Alright, go through and test all your numbers. So you would plug -10 into this equation and see what you get. So I'm just going to do the first one and then we're just going to go through it. So if you want, you can include this if it keeps you on track. So we'd have a +2 no matter what. -10 plus 4 would be -6. -10 minus 1 would be -11 over this 3 right here is not going to matter. It's positive. If you want to do the positive, just to keep things in order, that's up to you. -10 plus 2 would be a negative. -10 minus 2 would be a negative. So overall, since we have 4 negatives here, this section would be positive. Alright, then you would do the same thing for the other numbers, and if you do that, you get negative, positive, negative, positive. We want less than or equal to 0, so we want negative values. So if we do that, we will go from -4 to -2, but remember, -2 is part of our domain restriction, so we cannot have a bracket there. We have to put a parenthesis around it. Then we have a U. Come over here, this section is also negative, so it's going to go from 1 to 2. 2 is also a part of our domain restriction, so it has to have a parenthesis. So that would be our answer for that. Alright, last question that we're going to go through says sketch the graph of the rational function including all the asymptotes. So our equation is f of x equals 2x minus 4 over x plus 3. So let's go through and find our horizontal asymptote first. Horizontal asymptote, you have your options of Bobo, Bachu, or Betsy. If you notice this one, this has an exponent of 1, this has an exponent of 1. So this is Betsy. If you remember, Betsy means bottom equals top, we divide our coefficients. So our coefficients are 2 and 1. So it's 2. So our horizontal asymptote, remember it's going to cross the y-axis, so it's going to be y equals 2. So let's go through and dot that in. Okay, let's find our vertical asymptotes now. Our vertical asymptote comes from the denominator. Our denominator is x plus 3. Nothing is going to cancel in this equation because if you look at this numerator, you would factor out a 2 and you'd have x minus 2. That minus 2 will not cancel off that x plus 3, so our vertical asymptote is still going to be at the x plus 3. If it did cancel, if you remember, that creates a hole. So our vertical asymptote is going to be at x equals -3. So we're going to dot in our vertical asymptote at -3. Alright, and then what you're going to do is you're going to go through and you're going to pick some test, like x values to the left of your vertical asymptote and to the right of your vertical asymptote. I went through and picked exact ones. Some of them might be zeros, or decimals. Like if you plugged in -4, you might get a decimal as an answer, but you should be able to tell if it's above the horizontal asymptote or below the horizontal asymptote, so you can draw it. Alright, the first one I picked was -8, and when you plug it back into this equation up here, for the x's, you plug in -8, you get +4. So I would go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and we would have there. So we know our graph is going to be up here somewhere. So the next one I picked, and again, you're only going to have to pick one so you can figure out which quadrant you're in. The next one I picked was -5. I got 7 when I plugged it in. So your graph would look like this. Again, you just have to figure out which quadrant you're in based on your horizontal and vertical asymptotes. Once I knew I was in this quadrant, I'd be able to pick my answer. Then I'm going to pick to the right. So the first number I picked to the right of my vertical asymptote was -1. Plug in -1 to your equation up there, and you get -3. So if I went -1, I'd have to go down 3. So now I know I'm down here also. So I should be able to pick my graph for my answer choices just based off of that. The last one I picked just to figure out what the total shape was. And again, you're not going to have to go to this extent. Just pick one on each side so you can figure it out. So you can figure out which quadrants you're in, and that's it. You don't have to pick 2 from each. I did. But you just need to pick one so you can figure out if it's up here or down here. So it's up here, and then you need to pick one on this side of the vertical asymptote so you can figure out if it's down here or up here. That's it, guys. So again, make sure you go through your old assignments for 4.1 and 4.2 so that you can do well on this test. Good luck.